Okay, then I think we will carry on. So thanks. I mean, our next presenter is Baillie from Novartis, and he'll talk about ggsurvfit.
Don't worry, I'm also blown away by this, and I don't think I can even match the talk before. That was really impressive. Today I'm just going to talk about a package called ggsurvfit. It's a very small package. It solves I would say it's a niche problem within, say, medical research or clinical research, but it's a very important problem to solve. And I'll just give you some of the kind of features and the motivation of why we did this package. Yeah, just go through some of the licensing issues. So the real brains and like the hard work behind this is Daniel Sjoberg. He just recently joined Genentech. When we developed this package, it was this time last year. He was at Memorial Sloan Kettering. It was a kind of spin-off of another collaborative project. So I just want to highlight this isn't purely a pharma project, but now it may look like a pharma project. I'm more of a consumer of R, so I'll probably give some reasons why I'm also involved in this project as well. But really, I just want to highlight that Daniel is the brains behind this. Unfortunately, he's in San Francisco right now, so he couldn't make it today. As I said, it's a whistle-stop tour of this ggsurvfit package. I just want to give the motivation of why we developed it, because you may at some point think, this has been solved before, this problem exists, like it has been solved, why are you trying to recreate the wheel? I'll also give an overview of the package functionality and then just some additional examples that highlight some of the features here. It is a small package, but I think it's powerful if you do anything in medical or clinical research. So as I said, just the motivation. The package is essentially just for reporting or presenting time to event data. What I mean is data that's collected over time. So the kind of key estimator here is the Kaplan-Meier estimator. Is essentially the cumulative proportion of, say, events or deaths or something over time. Essentially, when you report an event over time, this could just be light bulbs failing, it could be patients dying, someone relapsing, heart attacks, etc. The Kaplan-Meier estimate, this is why I'm here. I'm going to give you some nice statistical trivia. The Kaplan-Meier estimate, if you don't know about this, it's essentially John Tukey, one of probably the most important statisticians, was an editor to JASA, one of the key statistical journals. He saw that there was two independent papers that were essentially solving the same thing. He asked them to write a joint paper. And 4 years later, they suddenly did this. So you can imagine probably the pain to collaborate. So when we talk about community and collaboration, this happened in the 60s and 70s as well. I think another nice bit of trivia here, and I'm being a bit facetious here, is Paul Meyer, one of the authors, when he looked at the Kaplan-Meier plots, he wasn't particularly convinced that this was a good thing to do. And if you look at the bottom plot here, you'd probably see why. And here I'm being facetious. This is essentially just using base plot to plot the survival object from survfit. You can make this look as nice as you want in base plot, but you have to be skilled in base plot. And essentially the problem that we are solving today is how do you take this object that comes from survfit, present this in something that's publication ready, and we'll use ggplot because essentially a lot of new people, when they come to R, they're more familiar with ggplot, the grammar of graphics, and base plot is really something that you have to be very specialized in, but you can do it this way. I just want to say this is not something that you can do in base plot. And so this is like essentially what I'm trying to say here is you take the analysis that comes out of a survival model, say for example, here we're really just leveraging on the survival package, taking the survfit object, and we're just rendering in a way that's almost close to being publication ready. So here you see this is like the generic of the package, ggsurvfit. Is plotting the object is coming out of survfit. You see this survfit2, and there's a reason for that I'll explain later. And essentially, this is close to publication ready. It's not quite there yet. So just to give you an overview, and it's a very simple package, the point of it is just to ease the creation of time to event summary figures using ggplot. We've developed a package to be concise and modular, and that's one of the reasons why we decided to develop this package where there's others that exist before. The point is to make it as easy as possible to be publication ready so that you can share your work as quickly and painlessly as possible and use sensible defaults. And I'll come back to that later on. I know this, I don't want to make this a pharma talk. If you work in pharma, you know about the CDISC model. If you use the CDISC model and your data comes from CDISC, then you can leverage a lot of the kind of advantages of using CDISC, but I won't talk about that today. And it also supports other types of, say, time to event analyses as well. So at the moment it has competing risks, say a cumulative incident summary. Essentially, if you can get your data into a tidy data frame that supports, say, time to event data, you can use this package. At the moment, it really leverages the survival package. So just why ggsurvfit? The main reason is ggplot allows you to do a lot of things. It's not enough support to do out of the box time to event analysis. So this is really trying to use ggplot2 and just add or extend ggplot2 and the object to be able to plot time to event analyses. The extensions are essentially geoms as well. So essentially when you use the ggsurv functions, you're not changing the ggplot object, you're essentially adding to it as well. So there you can use all the customization that you're familiar with ggplot. And that's one of the reasons and the motivations for doing this package. And you get some of the benefits, like say you use a standard ggplot extension, functions to say save and export or modify, etc. And I'll go into that into a bit more detail later on. Another advantage, and this is something that comes out of using this, say, the survfit2 function, which is essentially extending the survfit function from survival but capturing the colon environment. We can then safely do things like remove, say, additional things in the label that are very hard to do if you're using other packages. So say, for example, here when using survminer, which is probably the de facto package at the moment for time to event. And if you see here, you've got, like, say, the strata name, and then you've got the variable name equals in the actual label. And to be able to then extract that out takes a lot of effort. You need to know survminer, you need to know how to hack it to be able to do this. If you're doing this on your own, if you're using ggplot, this is something you also have to do as well. Here, it's taking some of these painful jobs and making them as simple as possible so that you can do this out of the box. And that's really the kind of spirit of this package, is to make things as easy as possible to publish, and you focus on the quality of the output rather than doing some of these painful tasks. So here's just a basic example of how it works. And essentially you fit a model. We don't do any computation here. We're essentially taking the model object, tidying it, and then presenting it. Here, it's just the generic function is taking the model object and displaying it. And then you have, say, additional functions. Say, I want to add a risk table. If you're familiar with time to event data, that's a kind of good practice to also show the summary statistics of how many patients are in your risk set over time. So just add the risk table, adds this component at the bottom. What's so good about this example? It's simple code. The figure is nearly publishable. We have the risk table now. We have the number of risks. The events are easily added. The x-axis gives a label for time. So if you were to look back to the survminer one, this is picking up the label data from the data set. So if you were using something like CDISC, you would actually get the specific information on the labels easily displayed. It's using ggplot2 plus notation. So if you're very familiar with ggplot2, it's not getting you out of the way of using that kind of syntax. But we could do better here, and this is where the customization is important. The y-axis label is incorrect. So if you know the colon data set, then the survival probability is not the right label for the y-axis. It's also, the plot has cut the data at, say, 40%. For survival probabilities, you want to show the entire range, so it's probably not the best default here. And also, because of ggplot2, there's a lot of padding that's been introduced. And say if you want to actually do something for a publication, you may want to reduce that padding. Also, if you look here, we're working on a scale of years. So 0, 2.5 years, 5, 7.5 years. It doesn't look like a sensible default as well. So let's do something better. So here, just using a very generic function within the package, we select the scale function. We also use the ggplot function to change the y-axis label. And as you see here, now this plot is probably close to publication ready. So again, some other things that we've done through this scaling function, we reduced the padding, we've given additional information on the time points, now we've got them spaced in terms of years, and we've updated the y-axis. We can also use extension functions of ggplot2, so here we're using ggeasy. Oops, I don't want to install that. We're using another, like the point that I'm trying to make here is you're using other ggplot2 extension packages to like make your life easy as well. So I'm using ggeasy to say I want to move the legend from the bottom to the top. Yeah. Okay. So that's just like, that's the core spirit of this. The point here is just to have publication ready graphs and make that as easy as possible. If you work in pharma, you've seen the quality of some of our outputs. Just making something with 1-2 lines of code will save so much time and effort. And if you think about the criticality of this, if, say for example, like the COVID vaccines, most of the readouts were time to event analyses. If you see some of the quality of outputs that you that we display from SAS or R, you can barely understand the treatment effects or the differences. So this is something that is critical, but it's a very sort of trivial package. And this is why I'm kind of interested in this, is like the quality of the output is really important here, and making it life easy for researchers is important. They don't need to figure out how do I hack a, say a monolithic package where I have to then say scrape away access labels, change certain defaults. It is a lot of hard work, and sometimes people say it's just not my job, I won't do it, and then they hand out something that's just really not acceptable for this type of work. So given the kind of motivational speech why I'm also involved in this, as I'm clearly not the best R programmer in the world, Daniel is, here are some examples of some of the things that you can do with this package. So the first one here is like we're taking the defaults, you've seen this before. Now we're just adding a confidence interval, so we just have a simple add a function, add confidence interval, and we're using a ggplot function to add the title. At the moment, with the title is just to say this is the default functions, and we display it. Now, say if we want to style this in sort of using ggplot syntax, we take the same ggplot object, the default, and then we can do all the types of things that you may be familiar with in ggplot. We change the axis. We maybe change the scales and also like the limits using very simple ggplot functions. Again, the same with the x-axis. We may want to change the colors of the treatment lines and the colors of the confidence bands. We may want to like change them so that they're, say, more transparent or like heavier set, depending on what you're interested in. You can then use themes within ggplot. You can say like where you want the legend. You have like full control here. That's really the main point. And again, you can add like you can change the axis titles and labels as well. So this is really just essentially an addition to ggplot. And so this is what the render graph would look like. You see, just from a simple using some of the ggplot2 syntax, we've really improved this graph. I think the other important thing to state is these are all ggplot objects, so then you can use packages like patchwork or a cowplot to put them side to side, so you can do additional things here. If you want to create a publication, you're not essentially creating like using a completely different type of object that doesn't go with ggplot. You can essentially use some of the sort of advantages of sticking within the ggplot environment. Other things, and probably one of the reasons why a time to event presentations are difficult, the risk tables. Is kind of essential to have this risk table information together. And so adding a plot and a table together really this is where the complexity lies. With the risk table, you can have a very simple risk table by just have this add function. You can then also then modify this, and it makes both the plot object and the table object kind of in line. So if you change anything in one, it will update the rest table so it's coherent in the other. So essentially you don't have two objects that are telling you different things. So for example, here we've used the scaling function, and now instead of like grouping the rest table by, say, the treatment group, we want to group by statistics. So if I was to go back here, we're essentially plotting the two treatment arms. And then if you look at the risk table, you see the risk statistics by the strata. Here we could just say, actually, I want to see the risk together and I want to compare them, then I want to look at the events together by treatment. And that's just something very simple, but it's very important. If your comparison is, say, at the treatment level, the strata level, or the estimate level, you can like modify this relatively simply. Other things you can do, and you see this here, is do I really want to repeat information, redundant information, say in the legend axis? You can like use like other like clever things here where I encode the risk table just to use very simple symbols to indicate what the treatments are. So I don't need to spell out this like treatment arm again. So it's essentially redundant information. You can do clever things like this with this package. You can further customize the risk table statistics that you use and say something like the glue syntax. So say instead of wanting the statistics in columns, you can put them side by side. And here, like we essentially putting the risks together and then the events in a bracket. You can do things like present quantiles here. So here we're showing the median survival. So again, just a simple add quantile function. At the moment, it's presenting the median at 0.5. You can have full control. You can have it at 75, 25, etc. Something very simple. Or you can do like summaries where you're essentially looking at what is the follow-up time, what's the median survival time, what's the survival probability at specific time points. So here, instead of focusing on the y-axis, we're focusing on the x-axis, and you can add as many of these summary statistics as well. And this is really something that's very simple, like the box. It's actually quite a lot of work to try and extract that from the SURFit statistics and then be able to put this back into like a presentation. We do all the hard work and the functions. And then now just to get to one of the things I think this is really powerful is KM communicate. I'm sure it probably doesn't mean a lot to you, but essentially this is like considered a good way to present time to event information. KM communicate is essentially short for a publication that surveyed hundreds of medical researchers and statisticians to find out what is the best way to present this information, because there's so many different ways that you can present time to event information. So this Morris paper in 2018, they tried to find, it's not so much a guidance, but essentially what is the best way to present this information. And they called their kind of consensus on this survey KM communicate. We can replicate the guidance here using a theme, essentially, this KM communicate, which is essentially the recommendation for, say, the BMJ or for other journals out there. It's very simple to do this now. And it's probably quite a hard work to do this on your own if you want to like program this recommendation up on yourself. Just maybe a note of caution here is just because it's a recommendation that you should do it, like this is the recommendation, you should present this information. That doesn't mean that you should just like take your brain out and think, okay, this is the way I'll do my time to event in the future. You need to think about what the purpose is here. So again, the point of this package is it allows you to do whatever you need to do. So if you think about your audience and aims and what you're trying to achieve, this package should be able to get you there. If you want to do something where you know that this KM communicate solution is the right approach, you have a theme to make this as easy as possible for yourself. So the KM communicate, you're probably interested what's so different about this. Here we have the syntax to essentially produce this KM communicate recommendation, and this is the recommendation here. So essentially, you have additional statistics that are presented in the risk table. You have the confidence bands, and you have the axis printed on the top right-hand side. So this is essentially the BMJ's recommendation. You get this with very limited lines of code. So with that, I just want to quickly wrap up. So ggsurvfit, it's a new, probably another time to event ggplot package. I think this one is, the way it's designed, is very powerful. You don't have to learn a completely new syntax if you're familiar with ggplot. This is essentially an extension to it. The code is concise and modular. It's close to being ready for publication. So if you work in research, you don't have to do a lot of work to make this publication ready. It has sensible defaults. And it also has support for other types of estimators as well. And then hopefully it will grow over time. If you're interested, it's on CRAN, and also the development version is now part of the Pharmaverse as well. Thank you, everyone.
much, Mark. I'm sure there's questions.
Thank you very much, very interesting. I have a question about, in the Kaplan-Meier curves, very often you also indicate the censoring with the ticks.
Yeah.
Can you also add this in your version?
Yeah,
you never showed it.
Yeah, you can. I cut out a lot that you can't do, and we'll have a demo later on, but it's essentially if you want to add censoring, it's just an add censoring call. So that's available.
So it's within this function, it's within this ggsurvfit function,
Yeah,
that's an option.
It's an option, and it gives you the option to customize your censoring or whatever you want. So if you want to just only show censoring on one arm, you want to show a certain symbol, color, it gives you that flexibility. It's essentially just, it's another layer on ggplot. So
it's another layer. It's not within.
But it's a function that helps you essentially add that layer. But it is possible to do it, yeah.
Okay, thank you.
So basically, are you going to use, like, okay, it's maybe a question to the bigger group, but are you planning to use it for the submissions, like for the FDA? Since I know there were some talks with FDA groups that they are really open to working closer with the sponsors, especially when it comes to presenting the data, so they're open to Shiny and so on.
Yeah.
But in the long run?
So an earlier version of this package, essentially the ideas of this package was part of the FDA test submission, but essentially the first version wasn't really pure geoms that were being used. So Daniel went back and fixed it all in this package. And if you want to know the story of the prior package, I'm happy to help. At the time, he essentially did this in his spare time. And last time I actually saw him, witness him do this in July last year, like within a week, he assembled this package. I guess James could probably answer like what the future is of this package, like now that he's at Genentech Roche. But the idea was to build this up and then make this available so that it would be submission ready. So when we say like publication, it's also submission ready. If I look at other packages that are probably widely used to do this type of work, I think there's risks in them. Here, this is like fully tested. It's got like code coverage. Everything is robust. We've wanted to test it. I would say it's ready to go, but we've been very careful about pushing this. I think if you want to, and I don't want to name other packages, but if you compare it to other packages that might have some landmines in there, I think this was a safe one to go. And the principle here is we're not doing anything to like the survival objects and model objects. We're essentially just rendering anything. So that's where I think it's a relatively safe package to use for submissions now. It's now part of the Novartis validated, how do you say, bundle? So it's validated, but I'm never comfortable with that word. I wouldn't use it, put it that way. And I'm sure it'll be fine for submissions.
Yeah, because it's like, when I see the ones that are generated by SAS and so on, it's like, especially like here, you have so much flexibility to, actually when you show the, when you scale the X, it's like, you don't have to be a statistician to interpret the results in a, like, it becomes straightforward pretty much.
Yeah, exactly.
The first side.
I mean, I have another talk where I can show you like some of the outputs of why we're motivated to do this. But we're like, we produce outputs for submission which aren't fit for purpose. This allows you to produce fit for purpose visualizations.
And ggplotly put on top of it, or can you make plotly plots on it? Or does that work? If you want to have it in a Shiny app or something, maybe you want to have some interactive plots.
I think I don't want to answer. I know that Tim, who's also part of this, was looking into this. I don't know if it's been solved, but I'd imagine you could do that, like the hack with Plotly, where it might give you some functionality with a ggplot, but I don't think it's not. I don't think we've extended it so you can use it with Plotly, but it might work. I don't know. We haven't looked into it. It's really, when we say publications, like just the things you print out at the moment. But it's probably something we should look into.
I want to talk, so this really looks great. I wanted to ask about customization. So for example, like you have the risk table and you showed the example where it was really big. I was wondering if that's already a use case where one could replace, let's say, number of events in a table by a plot also. Is that something which also can be extended, or that would be very difficult to do?
I think it would be, I've seen this in CERT, I think it is something that could be done. We haven't done this essentially with the risk tables, but given the syntax, you could do this. Essentially, this is a graph underneath as well, so you can start to change. So instead of displaying text, you could display statistics. I'm just wondering how you would do this so it's sensible. I'm not, but you can do it. And this is maybe just to, sorry, do we have
No worries, I mean, we've got plenty of time.
With this KM Communicate, they did look at all, like, how do you present all of this summary information? Is it numbers or like visualizations there? And they sent it on the risk table statistics, because essentially you want to look this up, that like the exact numbers. So I guess this is kind of then being the focus. But I think given it's a ggplot object, it should be easy to then do.
Cool. Any? Okay.
I quickly looked at the documentation. You have tidy functions, and so I suspect it would be possible to do what ggsurvfit does just by foot, by calling some of the tidy functions and then doing just raw plain ggplot.
Exactly.
Or am I mistaken?
It's essentially, if you look at the package, it's essentially some tidy functions, and then like some of the complication is how do you wrap the risk table into like a ggplot object and then combine them so that everything's aligned. So there's a lot of kind of helper functions, but to your point, it's.
But would I be able to render this risk table as a knitter cable or something else? So would I be able to get
I see what you mean. Yeah.
table?
Yes, you can. So I kind of use some of these helper functions to essentially do this type of thing as well. So like to get the statistics I want out of. So I essentially use this package as a tidier for CERFit anyway. And with the CDISC model, it gives me more than say using Broom at the moment. So some of the helper functions in Broom, it gives you a bit more customization. So there's the helper functions that are the utility functions for cleaning up the object are quite powerful, but like for like our line of work, if that makes sense. Yeah.
Cool.